Now, as I was saying you just now, that when dilute nitric acid, when it reacts, what happens? Moderately concentrated means we can also consider to be as dilute. We can consider to be as dilute. Understood? Moderately concentrated. So, copper when reacts with HNO3, which is cold and dilute, let us say, cold and dilute. So just now what you saw, what it will be given under moderately concentrated, I got nitric oxide and water I got it. So first you write it down which you know. So what you know, nitric oxide and water. Now what is going to form? Copper is going to react with it to form copper nitrate, CuNO3 whole twice. You can write it in 3 steps also, this particular reaction. You can write it in 3 steps. Alright, how you know? See, let us see. So first let me write it down, the reaction which I wrote it. That is moderately concentrated, I said. It can also be considered to be as cold and dilute. Alright, moderately concentrated. Listen carefully. So what I said it here, you will be getting nitric oxide plus nascent oxygen plus water. So what I did it here, 2, so it is 2NO and H2O and 3 nascent oxygen, we got it. Fine. Now copper will react with this particular nascent oxygen to form copper oxide, as you can see it here. Now copper oxide plus HNO3. Now how many nascent oxygen is there? 3 nascent oxygens. I will multiply this whole equation into 3. Remember it. Why? Because then only it will be cancelled. Huh? Here 3 nascent oxygen, if it is 1 nascent oxygen, then 2, then it will remain behind. But it is not. Whatever I am getting it here, I am using it here. Alright, understand it that after this step is coming. Means whatever the nascent oxygen I am getting, I am using it here. It's not that sir I will use 1, right? Then 2, what do you do? So you have to use the complete thing. So hence I multiply this equation with 3. Alright, just to balance it. Now copper oxide will react with HNO3. What you got it? You will get copper nitrate. Just now I said you, when acid reacts with base, it forms salt and water. Cu plus 2HNO3. Now you just add it as you did it in the previous case. But remember it, this equation is throughout multiplied with 3. That means 3Cu, 3O and 3CuO. You will be getting it. Fine. So next, what I am going to do, I am going to cancel it, whichever the common is there. So here you can see 3 nascent oxygen, 3 nascent oxygen. Opposite side, you cancel it. Then to balance it, this particular one, what you need to do is that here 3 copper oxides. So here also I have to multiply with 3 this equation. Because what I said just now to you, from here I got 3 nascent oxygen. So from here I got 3 copper oxides. I have to multiply this equation with 3. Then only it will, nah, because it's stepwise. Understand it, stepwise. After this step, after this step, this step. Alright, stepwise I am getting it. Alright, clear. So hence understand it. So 3CuO, it gets cancelled. Now, what it remains here? Here 3 copper, it remains. See here, 3Cu. So here you do not have to mug up the equation also. That is I am showing you here. Now here how many it is? 2HNO3 plus 3 into 2, 6. 3 is here. Hold multiply with 3. So 3 into 2, 6HNO3 plus 2HNO3. That is 8HNO3. Got it? Clear? Now, what you get it? In the reactant side, I think it's over. Yes, HNO3 is over, copper is over. Now on the product side, I have to see it. So product, what is that? 3CuNO3 whole twice. Alright? Then what is remaining? Now 2NO. 2NO is there. Yes, 2NO is there. Yes, 2NO. Now you got it 2NO. Plus water, how many? 3 water and here 1 water. That is nothing but 4 water. You got it. Anything is left? You just see. Copper nitrate is there. Done. Then 3 water and here water, 1 water, 4 water and here 2NO, 2NO, done. On the reactant side 2HNO3 and here 6HNO3, 8HNO3 and 3Cu, done. So in this way, see, it becomes so easy to write it down. Here if you are writing it, you have to remember it or you have to again balance it. Here no need to balance it, just simply add it, you will get the answer. Alright, here also same thing you got it. See, NO plus water plus copper nitrate, this, you got it. Same thing you got it. Now you have to balance it. You have to sit and balance 3, then 4, then 2. In this way, heat and trial method, you have to use it. But in this way, which I am doing it, alright, you do not have to go for heat and trial method directly. You can write down the answer once you write the stepwise reactions. So hence, what you are following here, that if I take hot and concentrated, I will be getting same thing except this. What is that? I got nitrogen dioxide. And if I take cold and dilute or moderately concentrated, I will be getting nitric oxide. Otherwise, the rest of the product is the same. Alright. So, in this way. Now, next, what I said you, two metals are there. Alright. In the previous area, I said you, 2 metals are there which reacts with nitric acid not to produce, alright, water. It gives you hydrogen gas. Only 2 metals. What are those? Magnesium and manganese. So, when magnesium reacts with HNO3, but it is very dilute nitric acid, means very means how much? 1%. nitric acid I will be taking it. 1% HNO3. That means what is that? 1% HNO3 means what? Suppose if you are taking 100% nitric acid, dilute nitric acid, out of that 99% is water and 1% is HNO3. Let us say 1 gram is nitric acid and 99 gram is water. So it is very dilute nitric acid. So under these conditions, only two metals, magnesium and manganese, they react with nitric acid, very dilute nitric acid, to give magnesium nitrate, and hydrogen gas is liberated. Here hydrogen gas is liberated, you can see it here. MgNO3 whole twice, and that is hydrogen gas is liberated. Only two metals under these conditions it will give you, no other metals. Why? Because I told you, if at all is hydrogen is liberated, that will react with nascent oxygen to give water, because nitric acid is a very strong oxidizing agent. Alright, I think it's clear to you. Now next, if when non-metals reacts with nitric acid, what is going to happen? Same thing. Non-metals like carbon reacts with nitric acid. What is going to form? Now carbon is going to get oxidized into what? Carbon dioxide and water. Got it? And what more? So here I have taken, what is that? Hot and concentrated. If I have taken hot and concentrated, what it will give you? It will give you nitrogen dioxide. Now you will say, sir, if I do with this dilute, no reaction will be there. With cold and dilute, no reactions. With non-metals. Because non-metals has got no reaction with cold and dilute nitric acid. Remember it. With hot and concentrated only. So carbon gets oxidized to carbon dioxide and water is removed. Got it? And nitrogen dioxide. You will say, sir, carbon dioxide and water will form carbonic acid. No doubt. Yes, it is going to form H2CO3. But H2CO3 is unstable acid. Again, it will decompose to give you carbon dioxide and water. But if you do the same reaction with sulfur, sulfur plus HNO3, hot and concentrated. Hot and concentrated. It will not give you sulfur dioxide or sulfur trioxide. Why? Because sulfur dioxide reacts with water, or sulfur trioxide reacts with water to give you sulfuric acid. And sulfur dioxide reacts with water to give sulfurous acid. Of course, sulfurous acid is unstable, but sulfurous will be very little, minute quantities. Sulfuric will be maximum, major quantities. Alright? Listen carefully. Here when sulfur reacts with nitric acid, of course nascent oxygen is liberated. It will give you sulfur dioxide and sulfur trioxide. Sulfur dioxide will be minute. Minute means hardly 2% sulfur dioxide will be there, and 98% sulfur trioxide will be there. That sulfur trioxide will react with water. Now you will say, from where water is coming? Like here water is revolved. Here also water will be evolved. Will react with water to give you what? Sulfuric acid. Because you know SO3 plus water, it gives you what? H2SO4. Are you following what I am saying? That like here carbon reacts with nascent oxygen from here to give carbon dioxide. Here also sulfur will react with the nascent oxygen from here to give you sulfur dioxide and sulfur trioxide. But not only it will give sulfur dioxide, sulfur trioxide, it also gives water. So sulfur dioxide and sulfur trioxide dissolves in water to give you what? Sulfur dioxide dissolves in water to give you sulfurous acid. See here, SO2 plus water is H2SO3, sulfurous acid. It is unstable. This acid is unstable like carbonic acid. It will give you SO2 and water. But this is how much? Hardly 2%. 98% is what? That is sulfur trioxide, which reacts with water to give sulfuric acid. So which one I should write? 98% I should write, or the 2% one I should write? Definitely the major one, 98% one. So hence it forms H2SO4 plus, that is H2O plus NO2. We can say it is being formed. Clear? You can balance this particular equation later on. Similarly, when phosphorus reacts with nitric acid to give you phosphoric acid plus water plus nitrogen dioxide. Nitrogen dioxide will be evolved because you are taking nitric acid, so nitrogen dioxide has to be evolved. Alright? Are you getting me? That here, why did not you write acid? Because here carbonic acid will be formed, which is unstable. Again decomposes to give you this and this, carbon dioxide and water. Here also sulfurous acid will be formed, sulfuric acid will be formed. Sulfurous is minute quantities, sulfuric is major quantities, so hence I wrote it. And sulfuric is not an unstable acid. It is not an unstable acid. It is quite stable in nature, we can say that. Clear? Understood what I said? Rest you write the equations and see. Like phosphorus plus concentrated nitric acid, you will get phosphoric acid, that is H3PO4 plus water plus NO2. Balance it. I am writing it, see here. P plus HNO3, hot and concentrated, will give you what? H3PO4 plus water plus NO2. You will say directly H3PO4 is formed. No. Just like this. First, P will react with nascent oxygen from here. It will get nascent oxygen from here to give you phosphorus pentoxide, P2O5, which dissolves in water to give you phosphoric acid, which dissolves in water to give you phosphoric acid. Got it? Because this is stable. Phosphoric acid is stable, sulfuric acid is stable, but here carbonic acid is not stable. So hence I did not write carbonic acid, I wrote carbon dioxide and water. I think it's clear to you that what I said about it. Thank you very much.